Welcome back to Garage Time, and today this video is going to be part 2 on the Porsche 912 engine tune-up series. Today is going to be focused mostly on the WEBER 40 IDF carburetors and the setup. I've learned a lot from the initial settings. This is when the car was not running well at all. It wouldn't even get out of its own way like a stoplight. Had a real bad hesitation between like 1500 RPM and 2000 RPM, which meant getting out of first gear and letting the clutch out was always like a big problem. Now I have a new group of settings that runs really well. This video will be a little different in that I'm just going to share with you some of my settings, some of the measurement techniques which are unique, and also the lessons learned. I did things the wrong way and came to some conclusion on what works. So I'm going to share all that information with you. Also, all the fundamentals, like there's so many things on the carburetors. There's the fuel pressure, the float level, the carb synchronization, the air bypass screws, the venturi chokes, the idle jet, the idle speed screws, the mixture screws, the air correction jets, the main jets, the emulsion tubes, and the accelerator pump. So I played with all of those things, and I'm going to share my results with you. Hopefully your engines can run well too. You know, the WEBER 40 IDFs are not stock on this car. It's supposed to have Solex P11s. Also, the distributor on this car is a replacement distributor. It's a Bosch 050, and it's not quite the same as the Bosch 022, which is what this car should have. I got to tell you a little something, actually running better than I remember my 356 running. Okay, so what's the secret to a good running engine? Well, it comes down to what I started with in part 1, that was last week's video, about making sure that your engine is in good condition. So last week I adjusted the valves, I measured the leak down to make sure that I'm getting good compression, good combustion in each of the cylinders. I also went through the ignition system, I adjusted the points, I replaced the spark plugs, I checked the ignition timing and made sure that the ignition wires were working well. External to the carburetors are something I touched on last week. The throttle linkage is very important. Because this car has dual carburetors, they have to work in synchronicity. And if they don't, then the engine's fighting with itself and you're never gonna be able to adjust out a bad linkage. So last week I ended up cutting my linkage and fixing it with the worn ends, making sure all the balls were tight. That was a big step forward. Also, something external to the carburetor is the fuel pressure. So I have electric fuel pumps in this car. So I'm able to adjust it with mechanical regulators in the back to 3.5 PSI. Some people go higher pressure than that if they have an engine that has a high demand for fuel. Maybe it's got a big displacement or a different cam, or it's revved really high. Some people go up to like 6 PSI, but you have to realize the pressure of the fuel actually pushes down on the float, and it can change the float level. So the float level is one of the first things we'll be checking. WEBER suggests a 10 millimeter distance between the top of the float and the bottom of the body of the carburetor. That's a static and dry measurement. I'm going to show you a wet measurement that is the actual float level. Sometimes these are old parts, so either the float might be old, it might have swelled, it might be a little heavier than it was when it was new, or the fuel pressure, like I mentioned, can also affect the float level. So what's important is the actual wet float level and its relationship to the place where there's like a brim where the fuel flows out of the well and down the throat of the carburetor. So if the fuel level is too low, it makes it really difficult to get the fuel up and out into the throat. And that changes the timing of when the main jets kick in. So the well, where the main jets are, is the same float level as the carburetor bowl. So you can take out a main jet stack and you can go down and check the level of the fuel when the engine's running, which is what matters. Okay, you've just seen me use these little paper flags to check the float level or the fuel level inside the main jet well. That was with the engine running, by the way. And this allows me to see what the actual fuel level is. And it's a little bit hard to use. You know, when you go down the hole, there's a little bit of fuel kind of vibrating around, and it tends to crawl up the sides of the jet well. So sometimes when you put it down, you'll get a little bit of fuel on the sides, but that doesn't mean you're at the fuel level yet. So it's a little hard to use, a little bit subjective. I was trying to drop it down pretty quick, but I think I ended up with a 48 millimeter measurement, and I was able to get 48 millimeters on both sides. So when you put it down and you get the bottom completely wet, that's you've hit the fuel. When you put it down and nothing's wet, then you're not there yet. That's not the fuel level. And the important thing is not really the number, but it's the relationship of the fuel level to the brim where it feeds into the throat. So I had measured that at 44 millimeters and the fuel level is at 48. So there's a 4 millimeter distance between where the fuel is in the bowl and when it starts to get into the throat. And that distance is really important because, as you can imagine, it works by Venturi effect. So as more and more flow goes down the throat of the carburetor, it creates a vacuum. And it works against the main air correction jet to pull that fuel up the well and into the throat. So imagine if they're uneven, they're going to be kicking in at different times. Or if you want to tune when the main jets kick in, you can raise or lower the float level, and that's just another one of those adjustments. Now, you can also change the air correction jet, which we'll get to later. That will increase the vacuum or decrease the vacuum on that column of fuel and change when the main jets kick in. But for now, we're okay with the fuel levels. At least they're even from left to right, and they're working. If I had a float that was sunk or damaged or binding or something, I would know by checking the actual fuel levels. So I kind of like this method. It really confirms that your carburetor is working correctly. So next up on the list of things to do with the carburetor is the synchronization. This is still an external measurement to try to get both carburetors flowing the same amount of fuel. And you saw me use this device last time. This is the commercially available synchrometer. This is made by STE, and it's called the Synchrometer Flow Meter. And you just jam this in the top, and it starts to register numbers. Now, the numbers are pretty close together, so if it's 4 or 5, it's really a short distance on that. So this works, it's fine. This is what everyone uses, and it synchronizes your carburetors from left to right. You can even synchronize the barrels on the same carburetor if you need to. Mine seem to be pretty even, but we're gonna do something a little different with that. I have this to try. This is a USB on this side, but inside this is just a rubber hose. But inside there is a hot wire anemometer. And what this does, it's really similar to a mass airflow sensor that like a modern fuel injection car would do. It basically heats up a wire. The more air that flows over that hot wire, it's going to tend to cool it. So they have to put more current into the wire to maintain a constant temperature. So this is a good way to measure airflow or mass flow. And I'm gonna be using this. It's probably a little bit more accurate than the synchrometer. And that's just, you know, that's just me. I love all these meters, and I'm an engineer, an engine nerd, so this is something I want to try just to maybe get a little bit better synchronization. Who knows if it's really worth it, but I have the tools. I'm just going to try it. Getting 0.72 on this side. It's this column right here. 0.7, 0.77. And over here, getting a little bit less. Oh, there's a 0.7, 0.57, 0.53. So I'm going to decrease this one just a little bit. Increase this one just a tiny bit. Increase this guy a little bit. Okay, 0.61, 0.64. Those are exactly the same now. And then if we go back to this method, it reads, you know, just under 4. Right about 4. So now I'm gonna push the gas pedal a little bit and see if we can get a off idle adjustment too. And this is my makeshift gas pedal depressor. It's got a little nut on there so I can dial in a little bit of speed on the engine and just keep it real steady. I had Alex help me last time, but it's hard to keep your foot really steady. So I'm hopeful this is about 25 pounds. Hopeful this will do it. That's pretty good synchronization on both idle and off idle. I had it set up to like 1500 RPM and the engine was running pretty smoothly, and I've adjusted this linkage before, got it dialed in to where it was pretty much the same left and right, no discernible difference. The next thing I was gonna do is I also made some new velocity stacks that have a pressure sensor inside, or just a pitot tube kind of thing. And I can run that while I do larger throttle depressions and see how that works. Okay, here's the custom velocity stacks, and they have a thin tube in the middle with a small hole. It's kind of a pitot tube, not quite, but that's going to measure pressure as I'm driving. So I'm gonna install these in the carburetors and monitor with this digital manometer inside the car, and that's gonna let me read the pressures as I'm driving. Here's that stack installed, and then there's a tube going right here, right through the hole in the firewall there, right where my roll bar is. This is the same on this side. So there's one on each side. This connection's going right inside to the passenger seat. Let's go. So that's the setup. This thing is a differential manometer. So it's gonna take the pressures of both sides and then subtract them so that ideally, if things are balanced, this should read 0 the entire time. Forgot my sunglasses, you can't see anything. Okay, let's watch it up this hill. Getting plus, minus, plus, minus. It's definitely fluctuating, but it's going from plus to minus. We'll do that hill again with one side disconnected to sort of see what the pressures were, because it was fluctuating a little bit, but it looked like it was going from plus to minus. And then at idle, it's just showing 0. I'm not getting much airflow at all. It only measures sort of higher airflows. There could be some pulsation, reversion coming out of the carburetor, and that could affect the pressure. About 0.2 or 0.3, but it does fluctuate quite a bit. The manometer pressure meter was kind of inconclusive. I mean, it did fluctuate between positive and negative, but when I looked at just the signal by itself, it seemed like the pressure wasn't as steady as I thought it would be. So you'd really have to average the measurement and do some more math to really make that useful. I'm not going to adjust the linkage because of that. I kind of thought it would work out better. The car is driving great. So at this point, the science experiments are over. There's no point in solving a problem we don't have. If the car runs great, then that's cool. Okay, next up on the list of things to adjust was the idle jet and things associated with the idle circuit, like the air bypass, the mixture screws, and also the high speed or idle speed screws. All those kind of work together. One thing I did is ran the car with the main jets removed. And that teaches you a lot of stuff about, where is the idle circuit functioning and where is the main circuit functioning. When you remove the main jets, it just disables all the main circuit. So what happens is, I remember we talked about the fuel level. When the air correction jets are out, there's no way for there to be enough suction in the fuel well to bring the fuel out of the fuel well into the main jets. So by removing them, even if you remove the main jet, you're not going to get fuel going into the throats of the carburetor because there's just not enough suction there. So it basically disables the entire main circuit. So I drove the car on just the idle circuit, and it was really eye-opening to see how fast you can go on just the idle circuit. And in terms of RPM, it'll go all the way up to 3,000 RPM under really light throttle. But the minute you're like in second gear and you open up the throttle too much, it completely goes lean and the engine dies. So you can transition to the main circuit as quickly as 1,500 RPM if you have a large throttle angle, or as much as 3,000 RPM if you're on or even 3,500 RPM if you're on a really slight angle, on a throttle plate angle. Now we're gonna run the car without the main jets. I took the whole stack out. That's the jet, the emulsion tube, the air correction jet, and the holder. So idle's fine. Right now it's about 700, 800 RPM. Hopefully you guys can see the gauges. I just started it, but the air-fuel ratio is about 13. It'll come down a little bit once it warms up again. Just gonna do a real easy first gear start. It's idle circuit only. And watch the air-fuel ratio. This is only the idle jets. It's at around 11 and a half. RPM is up to about 1,400, 1,300. Go around the speed bump. $1,200. So it's getting plenty of fuel. It's way down at 11 to 1. Real light pressure on the throttle. 11 to 1. 1,500 RPM. 11 to 1. 1,800. 11 to 1 still. $12 to 1. 1,600 RPM. Plenty of fuel. Still driving on the idle circuit, 2,200 RPM. $22, $24. $2,800, still driving on the idle circuit. Almost 3,000. There's where it cuts out. It's not so much the RPM, but once it tries to go a little bit more too much gas, it starts to cut out. Second gear, ratios are now 13. There it cuts out right there. Gets really lean. That's more throttle opening at about 1,800 RPM. Cutting out right there. That's 1200 RPM. That's 1200 RPM with more throttle opening, second gear. Okay, now the main jets are back in. Let's do the same lap and see how it differs. Same thing. $12, $11. That's 1800 RPM. 11, 2200 RPM, down to about 11. We're still on the idle circuit right here. 11, second gear. Light throttle, there's 1400, 1300, 1500, give it some gas. Comes right out. Idle circuit, main circuit. It's idling right there at 12.5. Real steady on the idle. But the minute you come off idle, it will dip down. Even if the brake's on, I can just come off idle a little bit and the ratio goes down. That's more rich. See it going down to 10 or 11? So that tells me the idle jet is small enough. And this is the 50. It's getting plenty of fuel. That experiment showed me that you need to go down in the idle jet to keep it lean right off idle, because if you get too much fuel right when you open the throttles, then it just gives you that bog sensation. So I went with the 50 idle jet down from 55, and it's still getting plenty of fuel out with the 50 idle jet. It still will go down to like 10.5 when you're at real light open throttle angles. And that's a result of the transition ports and the way the carburetor is designed to work. So I think 50 is the right number based on driving around on the idle circuit alone. Okay, I wanted to show you on a carburetor that's not a Weber. This is the Solex. These are the ones that are supposed to be on the engine actually, but I'm not using it. So I'm just going to show you here what the idle circuit looks like and how the throttle plate exposes different portions of the idle circuit. So the first hole here, well below the throttle plate, is the idle adjustment screw or the idle mixture screw. So we turn this thing in and out, and it controls how much fuel comes out of this hole right here. That's when you're at a dead idle, when the throttle plates are closed. And then as soon as you open up these throttle plates, it exposes more and more holes alongside the bore. Like this Solex has 1, 2, 3, I think 4 holes for the progression circuit on this particular one. The Weber only has 2. But what happens when you're driving around on the idle circuit, when the throttle is fully closed, you're just idling. You can control the mixture with the screws. But then as soon as you open up these throttle plates, you get more and more vacuum on these transition holes. That means the mixture screw does less, and the way you control the amount of fuel coming out these progression holes is by the idle jet. So that's what I was testing when I was driving around at small angles of throttle. I was trying different, exposing different holes here in the transition ports and seeing what it does to the idle mixture. Once you opened it up past about, a tiny bit, once the first or second hole is exposed, you're no longer controlling the mixture with the mixture screws, you're controlling the mixture with the idle jet. So there's two different kind of things you can do here. Yeah, the other important adjustment, and I think this was a big one on the way my carburetor was originally set up, is this on this carburetor. It looks a little different, but this is the idle speed screw on the lever that actuates these throttle plates. So what's important, and the way this was set up when I put the carburetors on by someone else, this was 3 turns in from the valves being closed. So these butterfly valves will come to a rest position almost touching the bores, and it basically just covers up that last hole on the transition port. That's how it should be. Mine was opened up so far that it was already exposing the transition ports. And what that does, it makes it really difficult to set the idle mixture when your car is idling, because it's coming, the mixture, the fuel is coming out of 2 different holes. So if you're having trouble or your carburetor is not responsive when you turn the mixture screw, it's probably because you're not using that actual port. You're using the one above it, and that's the transition port. So you're never going to get a good idle if you're running on the transition ports. So it's important that this throttle plate is just closed enough to where you're covering the transition ports and all the fuel is coming out of the mixture screw port. That's how it's supposed to work. The minute you gave it some gas, there was no transition. It basically went from the idle circuit, which was partially exposed, all the way up to like the main circuit. And that gave it like this really on-off feel. And that was the source of a lot of hesitation. So besides the jets being wrong, that idle speed screw was screwed too far in, and that's bad. It's important to have the throttle plates as closed as possible. And the Weber actually provides this something called the air bypass screw. And that allows you to close the plates all the way, open the air bypass valve, and that'll increase the idle speed because you have like a controlled path for air to come through. It's as if the plate was open a little bit more, but it's not. The air goes around the plate. So you can adjust that and get the throttle plates closed a little bit. I tried it all the way out to 1 turn, and you can improve the idle speed, which for this car was kind of important because it has a different distributor. I was trying to get the idle speed up, and you can do it, but what happens the minute you give it some more gas, it will go into like a rich condition because the air will take the path of least resistance. You open up the big valve, all the air goes through that one, and then the circuit that was used to bypass is no longer active. So you have less air, you have more fuel, and it just gives you this really rich condition, and it creates a bog right off idle. So you get too rich, didn't run well. So what I ended up doing is I closed all the air bypass screws to 0. So all the air is the same air when it's at idle versus when it's just tipping open. You get the same sort of ratio of air. That made the car drive a lot better. And then to get the idle speed up, I did have to adjust the timing a little bit on my distributor. I was very conservative, like at 32 degrees. I went to 35 degrees. It gave me a little bit more idle speed on the low side. And even though it's a little bit riskier at high speed, that's the compromise I have to do to get the car to run well on low RPMs. So that's something I will hopefully try in the future, is to swap out that distributor with the actual Bosch distributor. It has a little bit better advance curve, and most people say that it will cause the engine to run a little peppier at low RPM. The mixture screws were somewhat covered in the last video, but I use the color tune method. It's a spark plug that goes in the spark plug hole. It functions like a spark plug, but it has a little window in it, and then you connect the lead a little further away. You can visually see inside the combustion chamber and look at the color. So that's how I set the air mixtures at idle, air fuel mixtures at idle. You basically use the color of the combustion flame to give you the ideal mixture. And then once they were all even, all 4 cylinders, and the thing was idling correctly, then I was looking at the airflow meter that's inside the car. I was trying to get something like 12.5 to 1. So if the color tune was a little bit too lean, then I would just adjust all of them, open a 1/16 of a turn or 1/8 of a turn until I got the average air fuel ratio coming out the exhaust to be 12.5 to 1. So that's how I set the air-fuel mixtures for idle. And then just off idle, that was controlled by the idle jet. So once I put the 50 idle jet in and I closed all the air bypass valves and I got the throttle plate back where it was, covering the transition holes, the car started to run really well. So I left it at that, and then I started working on the main circuit. And the main circuit was 200 air correction jets, and it was, I think, 125 on the mains. And the emulsion tube is F7. That's what is included in that long stack. All three of those things are sort of important. And you can adjust all three. The F7s are, I have F11s and F7s. F7s have been recommended by almost everyone else. So I did copycat on that. I didn't even try the F11s because the car is running so well with the F7s. But you still have to choose the air correction jet and the main jet. And I was looking at the transition between the idle circuit and the main circuit and trying to decide which is the best way. So I got the car to run pretty well with 200 on the air correction jets, and then I had 120 on the main jets. And it was running pretty well. But the way to think about the air correction jets and how they work with the other ones is that, remember, in the fuel well you have the fuel level, and you have to create a vacuum to get that fuel to come up the well and into the main portion of the carburetor where it dumps down the throat. So by changing the air correction jet, by going smaller on the air correction jet, it allows you to bring in the fuel a little quicker because it has more suction. So it sucks that fuel up quicker. And from my idle jet experience, I know that the hesitation from the stoplight was due to it quickly coming off of the transition ports and looking for more fuel on the main. So by going to a smaller air correction jet, I was able to smooth out the transition even more, coming off of like a red light or a green light at the traffic signal. So it's almost like a timing exercise of how you do that. Now, the smaller the correction jet means the more fuel you're going to be sucking in too. So it tends to richen the mixture over the entire RPM range. So I went 175 and then 115 on the mains. The mixture goes down to like 11 and a half or 12 to 1 on full wide open throttle, even with the 115 main jet. So I'm gonna keep that one in. The car is really quick to respond with the 115. There's really no hesitation at all. Now the emulsion tube is kind of a little bit of a black magic thing. It also affects how quickly the fuel can get up into the throat of the carburetor. The more you emulsify the fuel, you add little bubbles into it, the easier it is to lift it up that column. So the way the emulsion jet works is you have air coming in from the top and fuel coming in from the bottom, and then there's holes in the side of the emulsion tube, and it sort of aerates the mixture. And the more light the mixture is, the easier it is for it to go up. So the emulsion tube does change the timing a little bit. And like most people say, just use the F7. For some reason, it does seem to work really well. I didn't even try to mess with the emulsion tubes. The last thing to adjust is the accelerator pump. And I had the accelerator pump screws mostly all the way out. And I've been avoiding any kind of quick stabs of the throttle or shifting. I don't jam the throttle when I'm shifting. I'm shifting really slow. I'm rolling off the gas, shifting, and then slowly rolling on the gas because the accelerator pump is mostly disabled. It actually makes the car a little hard to start too because you pump it and not much fuel is coming out. So now that the car is running well with the main circuit and the idle jet circuit, now it's time to tune up the fuel squirt that comes in. That's the accelerator circuit. The air is quick to move, but the gas and the emulsified gas has mass to it, and it just takes a little while to get that fuel flowing. So it's better to just squirt raw fuel down when you're shifting gears or jabbing the gas pedal like out of a turn or something like that. Okay, now I got the adjuster for the accelerator pump. We're gonna get that dialed in. Also, I'm gonna show you full throttle and what it does to the air-fuel ratio. Okay, we're just cruising along. It's about 2,500, 3,000 RPM. And right now the ratios are about 12 and a half
If I jab the throttle, see that marker right there? It goes really lean for a quick period of time. Little hesitation. So second gear. Okay, full throttle. Big hesitation during the shift because the accelerator pump is not really functioning. Okay, I've turned the accelerator pump in a little bit, about one turn. So let's watch. Still hesitates. So if you watch the meter, when you jab it, it's better, but it still whips over. But it's getting better. Okay, now when I jab the throttle, it doesn't bounce as much. It's getting better. I did one more full turn on the accelerator pump screws, and it seems like it's getting better, especially when I go all the way down on the pedal. It gives it a big squirt. You can really see this dot moving on the gauge. It reacts very quickly. That's better. No hesitation between shifts. Now when I jab the throttle, it still goes a little bit rich or a little bit lean, but not bad. I like it just like that. That's awesome. I'm gonna leave it alone. I'm done. Yes.
The tuning part of this car is fun for me. Even though this is the smaller 912 engine, I want to make it run as best as I can. And that's what my approach on this entire car has been. I gave everything I could to this car, including some special airflow tools that I just happen to have. So I tried my hardest to get that information out to you guys. And even things that were not recommended, like the air bypass screws, I spent a lot of time trying to make those work. And sure enough, I came to the same conclusion. They are just not, the car just doesn't run well with them open. So I gave you my best explanation on that. I hope this information is helpful. If you could, consider joining the Patreon page That's a subscription service. It provides a little bit of cash to Our Garage Time so we can continue to make these technical and informative videos, I hope, and hopefully save you some time. We have a long list of current subscribers to Patreon, so please consider adding. It's only $1 a month or up to $5 a month if you want.